Well, unfortunately, it looks like we're not going to be able to finish up the third part of our lab today. However, I'm going to go ahead and walk you through it and do a demonstration of the lab, so that way you can continue to work on your lab over Le Chatelier's principle. Now, what we're going to do with this last part of the lab is we are going to look at the equilibrium condition of magnesium hydroxide and figure out what is going to happen when I add acetic acid to it. Now, we've talked a little bit about this already, not in a lot of detail, but you really need to think about what happens when you're going to add this into solution. What is this going to dissociate into? And then is there any part of that dissociation, those ions that this dissociates into rather, that would react with any part of my equilibrium expression here? So if we think about this, this is an acid, albeit a weak acid. It's still going to contribute hydrogen ions to the solution. So when I add hydrogen ions to my solution, you may want to think about which of these species here it is going to react with. Once you've considered that, I want you to think about, is that going to increase or decrease the concentration of one of those two chemical species that magnesium hydroxide dissociates into? And then think about the shift in equilibrium. Now remember, Le Chatelier's principle is not an explanation as to why things shift. Remember that when we put stresses on something in equilibrium, that causes the value for Q to no longer equal K. So as a result, we're either going to form more products, more reactants in order to change Q so that it does equal K. So I'm going to go through and demonstrate this, so please follow along with investigation number 3 in your lab manual. So the first step says to add 5 milliliters of water to wells 1 and 2. So let's do that. Well 1. And well 2. Awesome. Fill well 3 about half full with white vinegar from the bottle at the shared material station. Fortunately, I'm at the shared material station, so. Oh, all right. That's half full. We'll go with that. Okay. So we're going to get some milk of magnesia. Now, milk of magnesia is what contains the magnesium hydroxide, not a sponsor. And it says, stir the white milk of magnesia liquid. So make sure we shake that up a little bit. After stirring, fill the pipette with milk of magnesia and place 25 drops in wells 1 and 2 of the reaction tray. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. All right, let's do that for well 2. Exciting television, I know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Cool. All right, and then we're going to stir. So okay, let's stir this one as well. A cloudy consistency here. Step 5. Step 6, obtain the bromothymol blue. So the issue here is that unlike the other ones where we could visibly see shifts in equilibrium, with the milk of magnesia, we're not going to see that unless we use a pH indicator. And you can think about what's, like I said before, what's happening when you're adding or removing hydroxide ions and how that impacts the pH of the system. So I'm going to get the bromothymol blue, which is here, and it says to add 6 drops to wells 1 and 2, and we're going to stir again. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. And we're going to stir that one more time. So we get fairly uniform consistency. All right, and we are going to take our pipette, and it says here on step number 9, stress 1, fill a pipette with vinegar from well 3 of the reaction tray, and add roughly half the pipette's content to well 1 and stir quickly with the pipette. And you're going to record your results in data table 3 for stress 1. And we're going to stir quickly. So think about what's actually happening here, right? Think about what happens when the pH changes, and then notice what happens afterwards. So let's go again. It says here for 11, repeat, step 9, quickly stir the tip of the pipette. I think I actually put in the whole thing, so again, we'll stir that up. Interesting, isn't it? And it continues to do this, and it says continue to add vinegar until a prompt color change is no longer visible. So I don't think I need to add a whole lot more here. Well, maybe. Keep stirring. Keep stirring. Keep stirring. Keep stirring. Okay. Not getting that prompt color change like we did before. So again, just think about what's happening here in terms of an acid and base reaction. That's what I really want you to think about and focus on. Remember what is happening when we're adding the acetic acid to the magnesium hydroxide. How does that shift equilibrium? And then also think about the change and what causes the change in color. Remember, we're using a pH indicator that changes color based on the pH of the solution. So just a couple things to think about. You can go through and analyze the rest of the lab. All right. I also want you to think about why not only did it change color to yellow, but why did it eventually go back to blue? Okay. And then eventually at some point, it doesn't quickly go back to blue. So think about those things as you go through, complete the rest of your lab. Yeah, we'll go from there, and hopefully we'll be able to get back together very, very soon. Thanks again, everybody. I appreciate your time. Jalen Bio signing out. Have a great day. We will see you soon. Bye-bye.